Welcome to the dynamic learning hub of XLR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. A hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Want to get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. XLR. We don't just train, we build careers.
Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it.
I was very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later from our college, I get to know about XLR and I enrolled in XLR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he is doing how real digital marketing works, and it was in total very good experience. I get so much of knowledge. Here they're not only focusing on study, they're also conducting different exam to test our knowledge, and as we are giving the exam, so to our
Dear students, good evening. Students, as I can see, there are let's participate, only 10 we have. So kindly inform your friends to join the session as soon as possible. I will play the video for 2 more minutes. Till that, kindly inform your friends to join the session. We will start at 7:10. I request everyone to ask to join, to join the session as soon as possible.
appreciate our work. They give certificates for the toppers, and along with the certificate they give hampers. Thank you, XLR.
Recently, I was searching for digital marketing courses online in Google, and I came across XLR, and I attended a digital marketing course which was for 15 days. My mentor Mayur helped me for attending these classes. So he is a very informative and helpful guy. In the course end, there is a exam which I topped. So I came to the XLR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, XLR.
I came to know about this course from my college. Actually, for learning platform, this is very nice, and I learned from here ChatGPT and AI from online. Because he's teaching for me for AI generative and ChatGPT. We are using this technology in more. And after finishing the courses, I came from for collecting the certificate. I seen the classrooms and faculties. Classroom is very nice. After the completion of exam, they will give gift and certificates. Thank you, XLR, for giving these courses. I learned a lot of from this. I gained the more knowledge from here. And thank you for XLR for teaching us.
Hello guys, I'm Vikram Mahajan and I'm studying in Swami Vivekananda Institute of Technology College, and I came across a training program which was mobile app development using Flutter, which was given to us by XLR Solutions. I came across this program through my college faculty, who told us about this program, that it is a very good course and you should enroll in this.
Asha, it's a good evening. Is I'm audible, sir?
Yes, ma'am. Yeah.
Yeah, you can start the class.
Okay, ma'am. Thank you. So today we will start unsupervised learning, and we will take under unsupervised learning the clustering. So let me share the screen and we will go in detail. Yeah. So basically, we have studied about supervised and unsupervised. We have seen the basics that how unsupervised and supervised learning works in our introductory video, the first day. So the basic of just that what is the difference between supervised and unsupervised we'll look, and we'll move to the one technique, that is clustering technique. Okay. So we have already studied that in supervised learning, what types of the data set we need. So generally, if our data set is labeled, we have classes or the target values. So we can apply the supervised learning techniques like regression, classifications. Okay. So if our data set is such that there is no target labels, no true labels, no target values. So what we can do, we can apply unsupervised learning techniques on those type of the data sets. So for the unsupervised learning technique, if you want to apply, you want to work on work using unsupervised learning techniques. So the basic thing is that you have your data set that is not labeled. So generally, if you see in supervised learning, so I always say that this, if you label something like that, input features. So input feature, if we have only input feature but not the target. So in this type of the data set, you can apply, target is not there, you can apply unsupervised learning techniques. Okay, so different types of the unsupervised learning techniques are there. We will see one of them, that is clustering technique. So let's move to the clustering. So let's understand first that what we are going to cover today. What are the main goals? That one is that we will understand that what is clustering. Clustering as a unsupervised learning technique in machine learning. And these two types of the clustering techniques we will understand. One will be the hierarchical clustering, and within hierarchical clustering, so these two, there are different types. There are different types of the clustering techniques, but we will cover today these two techniques. And within hierarchical clustering, we are going to cover agglomerative. So there are two different types of the hierarchical clustering, agglomerative and divisive. So, but we will cover the agglomerative clustering, and then we will see the k-means clustering. So let's first understand that what is clustering and what actually means by the clustering. So as name suggests that this type of the technique will form clusters of the data points. So cluster of the data points of similar data points, like in one cluster, the cluster, let's say we have data points. We will see an example with examples that how it will work. But let's say these A, B, and let's say one data point is C here and D is here. Something on the basis of you find two features. Let's say this is X1 feature and X2 feature. Okay. So on the basis of these two features, you plotted a scatter plot, and you can see that these are the points, data points A, B, C, and D. So just to find out the clusters, with similar data points will be in one cluster, and other similar data points will be in other cluster. So you can see here, we will discuss all the things that how we are going to find out the on what basis you can say that these 2 points are similar. So one way to find out the distance between the points. Okay, we'll see in detail. So let's say that these 2 points A and B are closer, more similar in comparison to these C and D. So they will form one cluster, and C and D, it looks that C and D are more similar, they will form another cluster. Okay, so this type of the cluster we have to make groups of the similar objects. So similar samples, similar data points. So you can say this is cluster 1 and this is cluster 2. Okay. And one thing is that we don't know the names, the labels of the data points. So we can give the name of the clusters as you wish. Okay, so you can say this is cluster 1, this is cluster 2, or the group 1 or group 2. Okay, so on the basis of the features of the data points, you can name the clusters. Okay, so there are different types of the different techniques to group the similar objects, similar data points, and within those we will see that how hierarchical clustering, this is a way that you are going to group similar data points, and other is k-means clustering. So we'll try to understand these two, and we'll try to implement also on 2 data sets. We will take 2 data sets and both we will implement k-means, and so we'll try to find out the 4 different types of the 4 programs we will do. So for the hierarchical clustering, we will implement on 2 data sets, and k-means clustering also will implement on 2 data sets. So we'll see that how these k-means and hierarchical clustering differentiates to each other, how you can implement, and what are the strategies you can follow, algorithm you can follow for this thing. So let's move to understand that what is hierarchical clustering first. Let's understand first clustering, and then we'll move to hierarchical clustering, and we'll see some basics how hierarchical clustering, that is agglomerative clustering, will take a type of the hierarchical clustering, how this works, and then we'll implement the hierarchical clustering, and then we'll move to the k-means clustering, and then we'll implement. So basically, when you think that what is hierarchical clustering, so you can see here the main purpose of this clustering or cluster analysis is to find homogeneous groups of the records. Records here is data points or the samples. Okay, data points, samples. If you have these type of the data points, let's say x1, x2, x3, x4. Okay, so 4 features, 4 input features you have, and no label is there, no output and no target is there. So the first entry, let's say 3, 5, 4, 2. Okay, so this is first record, your first data point, first sample. Okay, you have second entry, you have the second record or the second data points. So we generally say data points, we try to try to think as a data point the first row. Okay, second row, second data point. Okay, and in mathematics you can say that it is 4D vector, you can say 3, 5, 4, 2. Okay, this will be the first record. So this way, what we have to find the similar objects, similar records, or similar data points, and we have to group into one group. Okay, we have to put into one group, and it will depend on how many clusters you want, how many groups you want. So we'll see how it will work. And similar records or similar data points will go to the same cluster, and dissimilar will go to the different one. Okay, so we'll see all these things. So basically what we say, that what is clustering? Clustering is basically the way to group, the technique to group similar things, similar data points in one group or in one cluster. Okay, so and why we need clustering, why we do clustering in machine learning or in data mining or in data science. So the basic thing to understand the structure of the data set, the structure of the data, what is the pattern in the data. So we have to understand or discover the structure of the data. That is one, and we can summarize the data on the basis of the cluster center. So let's say that in one cluster 1000 points or data points are there. Okay, so all those data points are 1000 or 100 data points in one cluster, those have some similarities with each other. So we say that the center of the cluster can represent all the data points, those are in that cluster. So if you find the cluster, you can find data center, cluster center, and cluster center will represent the properties or the features of the data points that are inside the cluster. So we'll see. This is one natural example that you can find the clusters of the similar elements in periodic table. So they are grouped with similar properties. They represent in same color, they represent similar properties or something like that. So what different types of the things that you can perform using clustering technique. So clustering is basically what? You have data points, and now you are going to find number of the clusters, number of the groups. You are trying to find, let's say, 3 groups of the objects. So whatever, let's say 1000, 100 or 1000 data points you have. You want to group these data points into 5 clusters or the groups. Okay, but you don't know what is the classes, what is the labels of the data points. Okay, so we have to find out the similarity between the data points. So let's say that some similarity, we can find out the distance between the data points. Okay, so we can say that, okay, the points, those are the more closer, they are similar. Okay, so on the basis of this, you can find there are different ways to find out the distance and similarity. We'll discuss in detail. So let's say uh, if you go with average, so in each cluster, 200 elements, 200 data points will be there. Okay, but the cluster name we don't know, but we can group, we can find the similar data points. That is the main purpose. Okay, so we can find the types, how many types? 5 types, but we don't know the names of the type, but we can group the data points into similar type. So one is the application, or one thing that you can do, that is type of the pages are there on the web page. What different types are the web page? Yeah. So other what, customer segmentation is there, that you have 1000, 2000, more than that customers are there for a particular e-commerce website or any other things. Okay, so let's say that now the what is the main task? The main task is to group the customers into different groups, into different clusters, so that you can find that one group the behaves, how one group behaves, another group how another group behaves. So customer segmentation, you are segmenting, you are trying to find out the groups of the customers. That is also uh, one application. Social networking, different types of the peoples. What are the different types of the peoples on the social network? Okay, emails, you can find the types of the emails in the inbox. Okay, all these things already done, and these are well known clustering techniques. Okay, all these things are there. Genes, if someone is working on the medical and the genome and all these things, human genome. So basically, we have to find out the groups of the similar objects, similar data points. So let's move to the hierarchical clustering and the agglomerative clustering. We'll see under hierarchical clustering, we will see the agglomerative clustering. So we have to take two clustering algorithms. One is hierarchical clustering, another is k-means clustering. So basically, why it is hierarchy? So if we see, we go in detail and we'll see that it will create a hierarchy of trees, a tree-like structure of the hierarchy. It will create a hierarchy. So let's say that we'll understand that the similarity on the basis of, we are trying to find out on the basis of how it looks. So generally it's say that if you go and it's a 1 is more similar to the 7 in comparison to any other the number. Okay, so we group this 1 and 7 in one group. Now this 3 and 8 looks similar, some similarity. 3 is more similar to 8 in comparison to any other data point, like this 0 or 5 or 9, something like that. Then we find 4 and 9 are more similar. Then find 0 and 5 are more similar. Then we find these things. And we are trying to find out, and we are making the cluster of the clusters. Okay. So these type of the similarity, if you are going to work, you started from the single point, then you made the cluster of 2 points, then you made a cluster of more points, then you made a cluster of more other points. Okay, so we'll see these things in detail. Let's work with an example. Then we will see that how it will work. We are not going in detail too much about the theory, because we have to cover two algorithms and the practical also, and all these things hands-on practice. So we are going with example. Okay, and side by side I will try to make easy that how this example works, and then we will implement the clustering. Okay, so let's say this is our 4 points are there. Point 1, point 2, point 3, and point 5. So these points, let's say that this is feature 1, input feature 1 and input feature 2. So this is input feature 1, input feature 2. This is the item, the name of the item. So we can say record 1, record 2, record 3, record 4, or data point 1, data point 2, and data point 5. So let's say we have 5 data points, and we have plotted the scatter plot or any other plot, whatever you know. So on the basis of the feature 2 and feature 1, this is feature 1 and the feature 2 is there. So on the basis of these features, we plotted our data point. Now we have to, what we have to do? We have to find the distance. So distance, if you go, this will be something like that. This will be one data point. This will be second data point. Okay. Third data point, fourth data point. And this will be fifth data point. Now we have to find out a distance matrix that will calculate the distance between each other. Okay, so first each point, point 1, point 2, distance between same point will be always 0. Same point is there, so distance between itself, distance from itself, that will be 0. Distance between 1 and 2, data point 1 and data point 2. So how we can calculate? So that we are going to use Euclidean distance. So Euclidean distance, what it will do? It will just take under root and then subtract first feature values. So it will take 1 minus 2 or 2 minus 1, you do. Okay. Then square, then add the second feature, 1 minus 1 or something like that, and square. Then you will get, sorry, this will be 1. So it will be 0 and it will be 1. And now you have to find out the square and then under root. Then it will be 1. Okay. So this value is 1. Similar way, suppose that you want to find out distance between 3 and 4. So 3 and 4, what is that? 3 and 4. And keep in mind that it will be symmetric. So 3 and 4 are 3 and 4 here. So this will be also 3.6. So you have to find out you have to subtract the first feature square, then add subtract the second feature and square, and make under root. Okay. So this way you can calculate, you can find the distance matrix. So this is the distance matrix. And on the basis of this distance matrix, we are going to say that which two data points are going to group into same. group, into same cluster. So you have to find out the minimum distance, except 0, because 0 is already the same point, data point is the distance between itself. Okay, so we are not going to take it. So you have to find out the distance, that is the minimum one way that you are going to take. So this will be in between 1 and 2. So we are going to make a cluster of these data points 1 and 2. Okay, so what you will do, you made a cluster. Now you have to club 1 and 2 in same group. Okay, so what you will do, merge 1 and 2 into cluster A, merge 1 and 2 and make cluster A. And then single linkage is basically that there are different way that here you can see. Okay, so we have data points, we have different data points. So in single linkage, what we will do, we will try to find out two nearest data points. So how can you find two nearest data points? First, one way is that you have to find out all the distance between all pair of the points. Okay, so you find this distance, you find this distance, you find this distance using Euclidean. Okay, so you have to find out, this will be all the data points will have v1 and v2 values. Okay, so feature 1 and feature 2. Then the second data points will have features. Okay, it may be not only 2 features, maybe 3 features, 4 features, if 4 features are there. Okay, so we have to do same thing. You have to subtract x1, x2, then you have to subtract and square the second features, then you have to subtract and square the third feature. As many features are there, you have to do these things. So you have to find the distance between all the data points. You take the distance between all the points and find the minimum distance. So if you go and you check, that minimum distance is basically this one. So this will be the minimum distance, and you have to take that minimum distance as single. And complete, you have to find the maximum distance between the clusters, and here distance between centroids. So you have to find the centroid of the cluster, and you have to take the distance between those. Okay, mean link, you have to find all the distance, and then you just find the mean. Okay, so you'll see. So here, what we will do, we are using single distance, so the minimum distance we are taking. So we are going to take the minimum distance, and then we collect. Okay, so 1 and 2, here you see 1 and 2 are these two clusters, these data points are clubbed into one. So 1 and 2, from this row and this column, we have to take the minimum one. Okay, so that this will be 0 0, because now these data points become A, and this from 5.0 4.0, you to 4.0. From this is the minimum, you take this minimum, and this 6.7, this is the minimum. Now we have 4 data points, means 1 cluster and 3 data points. These are data points and this is cluster. Okay, so these things, what it will be, now we have to find same way. We have to find again a distance matrix, that these will be 3 4 5, these will be the actual original one. So these are the same. See, the data points are the same. Distance between 4 and 5, 4 and 5 is the minimum. Okay, so we have to cluster, we have to make cluster of 4 and 5. So this way, cluster of clusters, you have to make the cluster of the smaller clusters, and we have to go recursively. So now you can see from here, this distance matrix, you can find this 2.0 is the minimum distance. Leave these 0.0 because they are the distance from itself. So we are not taking that one. 2.0 will be the minimum distance. So we are, what is that? It is distance between 4 and 5 data points. Okay. So we are going to make a cluster of 4 and 5. So this way you can do, you can merge 4 and 5, then and make that as B. So now only 3 is there. So now you take what is the minimum distance, that is minimum distance is 2.2, that is between B and 3. So now you are going to make a cluster of B and 3. Now B and 3 will go in same. So you will see here B and 3 will be here. So this way, what we did first 1 and 2. We made 1 and 2. You can see here 1 and 2. We merged 1 and 2 first. Then we merged 4 and 5. Then we merged 3 with 4 and 5. Okay. So we find that there is two different clusters. We can find there are two different cluster. One cluster is containing data point 1 and 2. Another cluster is containing data point 4, 5 and 3. Okay, so this cluster B again contains one data point and one cluster, and this cluster that contains 4 and 5 is a smaller cluster or subcluster, you can say. So this type of the structure, if you are creating, so that structure is basically called a dendrogram. Okay, and why this is called hierarchical clustering? Because of that, it makes the hierarchy. It creates a hierarchy between the clusters. Okay, so first these two are clusters, then a cluster, then these two are grouped, then this data point 3 is clustered with these data points. Okay, so there are, now you go here, if you go back, you can find that here we are going to cluster 4 and 5. We clustered 4 and 5, then 3 and B. So we have to find out 3 and B because this 2.2, all these. So there are two different types of the distances that we need to cover. Okay, one distance is basically you are going to find out distance between two particular points. Okay, so you can use a Euclidean distance, that is this one. So this will be the first features, make difference between the first features, make difference between the second features, and if you have P features, make difference between P features. Okay, and square them and add them, then you can find the distance between those data points, respective data points. This will be in between the data points. Another distance is that is called linkage. Linkage is basically what? Linkage is basically you are trying to find out difference or the distance between clusters. Okay, so a cluster will contain data points. Let's say one cluster is containing these data points, another containing these data points. So now we have to find out the distance between these two clusters. Let's say any third cluster is there, this one. So we have to decide that whether this cluster is being grouped with this cluster or with this cluster, which cluster. Okay, so to decide that which two clusters you are going to make a bigger cluster, it will depend on the linkage. Okay, so on the basis of linkage, so we are working, we have used single linkage. We have to find out the nearest point, and here you can find the nearest point. Let's say this is the nearest point. Okay, so you have to think that this is the nearest point from these clusters, and from this and this you can find that this will be very far away. Okay, so this is the minimum distance for this cluster. Okay, you are taking from this and from this. So you are going to make a cluster of these two clusters, so bigger cluster. Okay, so this way when you want to make a cluster of the clusters, so that will be called a linkage that you are going to work on. So one way is to work using single linkage, that you have to find out the nearest neighbors in different clusters. Okay, so that will be if it is if distance is minimum, so these two clusters will be grouped with each other. Okay, now other way is the linkage is the greatest, that is the complete. So we have to find out the two farthest points. So on the basis of the maximum distance you are going to work, you are going to like make a single cluster of these data points. Averages that we have seen that you have to make the average, you have to take the average, all the distance you take from the respective data points, okay, one data points with each other, and you find the average. Centroid, take the centroid of the two clusters, and then on the basis of the minimum distance of the centroid you are going to take. Okay, so this is the representation. So let's move to the a data set that will be easy to understand. Okay, so this is SAT score is, let's say this is feature 1, and top 10 this is feature 2, except this. So we have 1 2 3 4 5 6 features. Okay, so on the basis of this, how you are going to represent. Okay, so let's say that this Caltech, the second data point, how can you represent using these points? 14 15 14 15, then 100 25 6 63,000 these, and 81. So you can find, you can write like this. Another, that is Cornell 1280, and these things you can write 1280, then 83, these things. Okay, so this will be the features. This is the first feature, second feature, then third, fourth, fifth. So how you are going to, suppose that you want to find out the distance between the Caltech and Cornell University. So you have to go with the Euclidean distance, and this is very good example that you can find. Okay, so respective features, just 14 15 minus 1280. So you divide, subtract, and square. Then you take second feature 183, subtract and square. So as many features you have, so do these things as many times and square, and then add and take the square root. That will be the distance between those two data points. Okay, now you have to find. So this way you will started and these data points, and then you made a smaller cluster, then bigger cluster, then more bigger, then more bigger. Okay, this is basically what a tree-like dendrogram or diagram is there, that is called dendrogram. Okay, that we have seen. So what it will do, how many clusters you can see? Okay, 1 2 3 4, then okay, 4 clusters are there. So there are different ways. That one is that you draw a straight line, horizontal straight line, passing through some of the vertical lines cutting. So just we decide that which one is the maximum, having maximum vertical distance. So you can do this. Okay, so you can say here, you can say, so you can decide that this distance is basically the maximum comparison to this, or something like this. So you can draw a straight line passing through this. Okay, so just like this. And how many vertical lines it is cutting? So that will form a cluster, that many clusters. So that is the simple way. So this will be this one, another cluster, another cluster, clusters. So cutting the dendrogram horizontally will give you the number of the clusters. Okay. So this is the way you can cut. If you're cutting here, you will get 2 clusters. You're cutting here, you will get 1 to 3 cluster. You will get 4 clusters, this way. So let's move and just implement. So before that, I am again sharing this, that you go and download these unsupervised learning clustering. Okay, this one, that is unsupervised learning and clustering. So within that I have uploaded 4 files, 2 Jupyter notebook files, IPYNB files, and 2 CSV files. So we'll take these 2 data sets and we'll implement hierarchical clustering and k-means clustering also. Okay, so you download this, and here, I'm just sharing the link in the chat, and you can go directly because from day second I'm sharing this, so you can go and you can go here directly. This is also that okay. You can find day 2, day 3, day 4, all these. Okay, so download these files and we will start working. We will implement and we'll see that how hierarchical clustering, that is basically uh, our agglomerative clustering works. So let's move to our command prompt and open the Jupyter notebook. So I'm using Jupyter notebook on my local machine. Okay, you can use Colab. I will show how to use Colab. Okay, so let's see here. So just open Colab, and daily I am just doing these things because you could understand. Okay, so just you go and upload whatever you have downloaded. So day 3, so go for the day 4 one, and you will have these IPYNB after downloading. So we are going to implement hierarchical clustering, that is basically agglomerative we are working on. So when you go and you upload, then your Jupyter notebook file will be uploaded here, whatever you have downloaded. And for that thing, you need customer dataset, customer.csv, and you need, I have also worked on university data. Okay, so you need universities data, universities.csv file. So these two files you need. So you go and upload here. You go and upload here those files. So you can upload customer as well as universities. Okay. So you can upload these two files, and respectively I have worked on the Colab only. So I have given the path as it is. Okay. So as it is required. So you need not to work anything. You need not to change the path and other things. Just you go and whatever I'm doing in Jupyter Notebook, do in this Colab. Okay. So just to understand that how it works. Okay. So let me work on the Jupyter Notebook. So just open Jupyter. Okay, you can use any terminal. Your command prompt is there. Yeah. So it will open this interface. Go to the where you have downloaded the files. You have where you have files. So I have here the files. So I have hierarchical, agglomerative, and the k-means. So let's first implement the agglomerative cluster. So the data set, the path I have to change because that I worked for this on Colab. So I have written that using the respective the path of the file, this file. Okay, so just if your file data file is in same directory where your this clustering IPYNB file is, so you need not to do any more things. Just write the only file name. If you have in different location or in different folders, so you have to give the respective path accordingly. Okay, so for that thing, always what we need. So generally the numpy we need. Okay, so you need numpy for numeric computation, and the pandas for the data set. So read the data set CSV files, and matplotlib to make a plot, different types of the plots you can plot using matplotlib. Okay, and the main thing is our agglomerative clustering that we have worked. So you can go and you can find sklearn. So you can check scikit-learn. Okay, scikit-learn and agglomerative clustering. Okay, so you go on the official website of the scikit-learn, and when we are working, so we have to import scikit-learn as sklearn. Okay. So here we are importing scikit-learn as sklearn basically in Python. So you can go for the agglomerative clustering and you can check all these things. This is basically a class, okay, Python class, and that is cluster. Okay. So this cluster is basically a module of this sklearn library. So agglomerative clustering, that is a class, and it will give all the things. Okay, number, how many clusters are there? So these things you have to go, and yeah. So these you can check all these things. Okay, how it works. Their examples are there. You can use dummy data. Fit is there. Fit predict. Okay, all these things are there. So let's move and do accordingly. So just run first. So you have imported all these things with uh, agglomerative clustering. This agglomerative clustering is basically a class. Okay. So just now read your data. So customer data, you can give the name, any name like data frame or DF or data. So we are working on the customer. So we are giving it as a customer data. Okay. Now you can find out just to check that how many features are there. So 1, 2, 3, 4, 5 features are there. Okay. But customer ID will not make um, any sense in the while clustering. Okay, male female is basically also age. So just we are taking these two, income and spending score. These two are the most important features that will make most of the decision while clustering. Okay, so we will take annual income and the spending feature. So, and we'll do. Okay, so our data, we just taking the data as only these two, annual income and spending features. Okay, and of the first three features, we are omitting first three features. And you can take age, you can take ID is not important because it will not make any effect on our that. Gender, you have to work on the categorical data. You have to deal with categorical data. So we'll see how to do feature engineering in detail in the upcoming sessions. Okay. So this type of the data set, if you have in which many categorical fields are there, categorical features are there. So how you are going to deal with those things. So you see, we are taking the data only these 15 and 30, 15 and 39, 15 and 81, and 16 and 6, 16 and 77, 17 and 40. Okay, so these are the data, and these are basically when you take like this, it will give you array, 2D arrays basically. So what we have to do, just to find out a dendrogram, just for the dendrogram, another library is there. That is SciPy. SciPy, you can go and you can check SciPy, and you have to install also. So how you can install? You can go and you can go for this SciPy pip or pip SciPy. Then you will go on this website, pypy.org. Okay. So this will give you how to install the SciPy. Okay. So just pip install SciPy. The latest version will be installed. That will be 1.15. Okay. So for any library, you can go and search. Here, let's say scikit-learn you are searching. Okay. Scikit-learn. So what it will go? You'll find here. You'll go and pip install scikit-learn. Okay. So you have just copy and run the command. So you can use command prompt, and you can use just pip. Sorry, we have copied pip and this. You can do this one. Pip install another library, that is SciPy, that we are SciPy. Okay, so you can install. I've already installed all these, so I'm not going to install again. So go and install first all these libraries, that is SciPy, and other library pandas, numpy, matplotlib, and scikit-learn we have already installed. Okay, So this is a new library that will work on this. That using this library, you can find you can plot basically the dendrogram. So just you have to import hierarchy. Okay, cluster dot hierarchy. So scipy dot cluster dot hierarchy. So we are taking one first letter from all these. So SHC. So imported this scipy dot cluster dot hierarchy as SHC. That is first letter of these three words. Okay. This is library module and this is a class. So you will do what you will do. You have to make a figure. This just now dendrogram will be. So from this class, this dendrogram, what is the linkage that we have studied? So you can find there are linkages. There are different linkages work where it is agglomerative clustering. This is linkage. So linkage, different types of the linkage are there. So we have studied, sorry. So we have checked different linkages. Okay. So complete, average, single, and word is there. So word is basically default, and you can use any single, average, or complete, or any one. Okay. So here word we are using. Mostly word is used. So you go with word. Okay. You can use single or the other linkages. Okay. So linkage is basically what you are going to find out the distance between two clusters. Okay. Using this method. So when you run this one, okay. So you'll find this this dendrogram. So what is that? Customer data set is there. For the customer data set, we have data points. How many data points? We have 200 data points, and each data point contains here, and we are taking only two features. Okay, these two features, annual income and the spending. So now here you can decide that how many clusters you need. Okay, you need 3 clusters, you go with this. Okay, so this also suggests that this is the best way that you can find in different colors. It says that this will be one cluster, this will be another, this will be another, but you can find more clusters. Okay, you can check for the more clusters. So if you go, you are cutting here, so you will get 3 clusters. One is this, and other one is the green one, another one is the red one. Okay, if you are cutting here, so you will get the 1 cluster, 2 clusters, second, third, fourth. But what is the optimal way to find out the cluster to cut? How you are going to cut? Just you have to find out, draw the horizontal lines, these horizontal lines, these horizontal lines, okay, these horizontal lines, and now you have to find out. Just you check that which distance is maximum. So let's say this distance is maximum. Okay, so you cut this distance somewhere. Okay, in between. So you will get 5 clusters. This is so using dendrogram. This is the way. And another methods, there are different methods are there. You will see in k-means clustering that there are another method. There are other ways to find out the number of clusters. Okay, so maybe that distance that I have done, that maybe this one is this one is the maximum distance. Okay, so you will get the 3 clusters. Okay, so on the basis of that you draw in a proper way. So let's say we are going for the 3 clusters here. Okay, so what will be now 3 cluster are the 5 clusters. If you are going cutting here, so you will get 5 clusters, and now here. So if you are going for the 5 clusters, the maximum number of the clusters where you have to stop. Okay, so what it will do, it will do up to here. Okay, so it will create 1 cluster, 2, 3, 4, 5. So it will stop at the 5 when the maximum, the minimum one, basically minimum clusters are remaining. So only 5. So if you are giving here 5 number of the clusters, minimum number of the cluster 5, so it will stop here for the 5 clusters, and it will give like the number labels of the clusters. Okay, 0, 1, 2, 3, 4. And if you are saying that 3 clusters we need, okay, so it will go up to these clusters. It will fill up all these things into one cluster, this one, another. So it will depend on how many clusters you need. So you can decide, okay, metric is basically what? That you want to find, how you want to find the distance between two data points. So that will be metric. We are taking Euclidean. Linkage, you are going to find out the distance, how you are going to make cluster of the two clusters. Okay, so on the basis of the linkage, how two clusters are similar. So on the basis of linkage, we have seen different methods. So this agglomerative clustering is basically what? This is a class that we have taken from the sklearn dot cluster. Okay. So this is, now you have to find out the object of this class. You created the object, and basically this is model. Okay, you can write here model, no issue. So this is your model. Okay, whatever you can write cluster model, you can write anything. So let's see, that is this cluster. This is our model basically that we need. So we have to create this. This is the cluster. This is the model, and we made an object that is named of the cluster, and this is our model, that is clustering model, agglomerative clustering model. Okay, so this model, yeah, so this will work as model. Okay, don't confuse with this thing. And model, and you can now, for the unsupervised learning, so there is no label, or the target values. So you can go directly fit and predict. You can also go in separate way, but you can go directly fit predict. Okay, so it will train and it will give the output, the labels. Okay, so these are the labels are not there. True labels are not given. Target values are not given. But it will try to find out number of clusters. So if you are trying to find out number of 5 clusters, so number 5 clusters, so it will give label like 1, 2, 3, 4, 0 to 4. Later on, you can decide that what is the name of the clusters. You can say the cluster 1, cluster 2, cluster 3, and something like that. But it will give you labels, label of the class, label of the clusters. So 0 to 4. So this way you can find directly, you can predict the class label or the group label or the cluster label. Okay, these are not the actual labels, these are not the actual classes, but it will represent that whatever the data points are under this group, they are more similar in comparison to other group data points. Okay, so let's move, let's run this one. Okay, you can go with a different one. Okay, so where it is, yeah, so let's create a different one. So what we are doing, we have created a model name is cluster, and this agglomerative clustering is basically what? This is our class. Okay, so we have given all these things. Now we have to train this model, that is cluster, and predict for the data that we have. So data is basically what? This is 2D array, and we are taking only annual income and the spending on. Okay, so these two features we are taking, only these two features. So because they are more important, and other like the A's and the ID, and these are the not important. So we are taking this. So let's run this one. So you'll get the labels. So you run this, so you'll get the labels. The first data point belongs to the group. 4, the label 4. The second data point belongs to the level 3. So third data point belongs to level 4. The fourth data point belongs like this. Okay. The last data point belongs to the level 2. Okay. So group, you have different groups 0, 1, 2, 3, 4, because we tried to find out 5 clusters, number of the clusters. Okay. So you get 5 5 different labels for each data point. Okay. Now what you will do? Now you can club the data points, the labels with actual data points. So for that, what we have used this one. So you can find it. So you see, so just we are going to use actual data point, that is customer data that we have before taking these annual income and spending. So we are taking all the features, and then we are adding the class, adding the group, the clusters. Okay, what will be the cluster? The cluster is 4, cluster number is 4, cluster number is 3, cluster number is 0, 1 or 2, something like that. So what you will do, just you create this cluster as a data frame for the labels. Okay, so you can check in a separate way, you can check separately that how it looks basically. So just you can see that how clusters will be. So run this one. So what cluster is? So it will give you a data frame of the clusters only for this. Now this data frame and the actual data frame we are going to. This is also a data frame that we have created, and this is a data frame. Now we are going to concatenate these two data frame. So with axis, this axis one, that is column wise. So you just run this one, and now you will get data. This data is basically this cluster. You have the cluster also. The actual data frame was up to this spending score and this. So now you can check that the first record belongs to cluster 4, the second record belongs to 3, and like way that 200th means 200th record or the data point belongs to cluster. Okay, you can visualize using Matplotlib that how these things. What is the problem? Key data size and so data on that is cluster labels. Okay, see cluster labels. So the labels. Okay, so I have to check with this that how you can work the data actually data before we take data before concatenating. So just take this as data, and now we can go and let's see that if it works or not. Yeah. So so I have taken this cluster also included in that, and but we need only these two features. Okay, so we can plot with only two features, because for the 2D plots only we need two features only. So income and this you can. So now you have taken income and this, and labels will be there, and different, you can change the color. So you can find here that all the five clusters are separately, you can visualize in different color. Okay, so these are the plot using Matplotlib. You can see here how are the different. Okay, so let's work quickly on the, because we don't have too much time, on the university data. So same way everything will work. Okay, we will take scipy dot cluster hierarchy as such to make the dendrogram. Okay, then agglomerative clustering, then pandas, libraries, all these things. Okay, so just university, but I'm not in the collab, so I'm giving the this path, And here also you can work, you can normalize. Okay, so we will see all these things, normalization and all these things, when we work pre-processing and feature engineering in detail. Okay, so you can do this. Just go for the dendrogram, that you can find the dendrogram how it will look. Okay, so for the university data, it will look like this one. Okay, so this is another cluster. This is another cluster. This is another cluster. Something like that you can find. And when you are taking 4 clusters, metric is Euclidean and linkage is single. Okay, so you can find what is the linkage and different other things. And here just our cluster, this is our model as HS. You can give any name like model or the clustering model or something like that. This is predicted. Y predicted means Y, basically we don't have the Y as classes, but fit and predict will give you the labels. Okay, 0, 1, 2, 3, 4. So four clusters we need, so you can find 0, 1, 2, 3 up to 3. So it will give. Okay, you can create the data frame of the clusters same way as we did in earlier, the first one. So 24, 25th, just run this one, this and this, and you can find after normalization our data. You can check for the university data here, that how university data is basically. Yes, so your university data was like this. So it has this university name, these university names, but we are taking only these features that are numeric features. Okay, these are the important features. So we'll take these features, we normalize. So after normalizing, you will get the features looks like, feature values are like this. Okay, so after normalization, you will get the feature values in between 0 and 1. Okay, so you can check all the features are in range of 0 and 1. So that is normalization. And this is normalized data. Okay, and this is basically your actual, or whatever the, not actual, but it is the cluster ID can say 0, 1, and 2, 3, because we need 4 clusters. So I hope you understood about the clustering and basically agglomerative clustering. We implemented using 2 data sets, and you have seen that for the first data set we have taken these 2 features, only 2 features. So if you have 2 features, you can plot the scatter plot. Okay, that is easy. But we have here more than 2 features, 1, 2, 3, 4, 5, 6, 6 features, 6 numeric features. We are taking these features for this, so you can find respective cell. So main task of the clustering is basically what? Main task of the clustering is to find out the group or the labels of the input data points. Okay, so you have data points but you don't have labels. So while doing the clustering, we try to find out number of clusters, and we have to assign, we are assigning the cluster number or the labels to the respective data points. So let's move to the next type of the clustering. And again, I'm saying that go and download the data set and the notebook also, so you can work on these things. So let's move to the next, that is our k-means clustering. Okay, so the next is our k-means clustering. So we will work on the k-means. Okay, so basically k-means clustering works on the centroid. Okay, centroid is nothing but, suppose that your data point, you have 2 data point here, and let's say its value are like 2, 1 and 3, 3, 1. not exactly 3, 4, you can say, okay, 1, 1 you can find here. Okay. ABC, 3 data points you have. So what will be the centroid? You have to add the respective features, let's say X features, 2 plus 3 plus 1, then divide by number of the features, okay? 1, 2, 3. Then what you will do? You have to add 1, 4, and 1, then divide by 3, because 3 data points you have. So you'll get 3 and 6. You have to do these things, and you will get somewhere in between of all the data points, you will get a centroid. Okay, so that will be your centroid, and on the basis of this centroid, we are going to work to that. So you see, this is the mean basically. This is the mean. So mean or the centroid when we are talking going with the mathematics. Okay, so that will be working. So how it works? So we have to see. So for this, we have to first decide that how many clusters, how many uh, groups you need, how many different groups you need. Okay. So again, for this k-means clustering, you have to find out the number of clusters. Means you have to decide earlier. Okay. So how you can decide? You have to work on the trial and error. Okay, you have to work for some 5, 6, 7, 8, 9, 10, and you see how it works. Okay, so on the basis of number of the clusters, we have two different methods. We will see when we do program using both methods. One will be elbow method, and other will be Silhouette coefficient or Silhouette value. So using those, we will try to find out the optimal number of the clusters. Okay. So let's say that you decided 3 clusters or 4 clusters we need. So all the clusters will be non-overlapping, means one point will not be in more clusters. Okay, more than one clusters. So these are the all the data points in the same cluster will be homogeneous, will be more similar. Okay, homogeneous when we talk homogeneity means they are more similar. They are similar to each other within the cluster in comparison to other cluster elements. So hierarchy, we are not going to do hierarchy in the k-means clustering. We can't find the hierarchy within the clusters. Okay, intra-cluster or inter-cluster hierarchy we don't have. So this way, and we will work. We will see how it will work. So let's see that with example. Okay, so again we are taking the same example, and so two things you need for this thing. You need number of the cluster, that is k, that is k means you say. So you need yeah, how many cluster, that will be different. K means is another thing, not that one. How many difference yeah. So before that, before starting, what the things we need basically, if you have decided like 3 clusters, if you decided 3 clusters, then you have to either you initialize 3 data points at the centroid. Okay, you can initialize 3 data points, 3 data points as centroid, or you can initialize 3 centroid that is not in your data points. Okay, any other, or you can randomly take 3 data points. Okay, that is not in our data set. So first you have to, you say that 3 clusters or 2 clusters are there. So you have to first define those 2 centroids. Let's say centroid 1 and centroid 2. So first important thing is to find out the centroid. As many centroid, as many clusters you need. Okay, so if you need 2 clusters, so you have to. So one way to find out the initial clusters, initial centroid basically, is to work with the data point. Okay, so you can take, so let's say that we decided for the 2 clusters. Okay, So you can take any point. Here it has taken this data point, this data point. This is not the actual data points. What other thing you can take? Two. You can take two clusters. If you are going to find two clusters, you can take two data points. So it says that anyone, like say you can take this one or you can take this one. On the basis you start working on this. Okay, you can take this as cluster and this as cluster. Okay, but what we have to do? We can decide that these data points belongs to one cluster with centroid this, and these are the data points that belongs to one cluster. So initially we have to initialize. So the initialization is important in the k-means clustering. Now when we initialize for any machine learning, or the deep learning, okay, training task, when you are going to train a deep learning model or machine learning model, initialization is important. Okay, so you just initialize. How you are going to initialize? There are different ways to initialize. Okay, but let's say that you initialize that these three data points belongs to a cluster, that is A, and these two data points belong to a cluster, that is B. Okay, now you have to work on the cost function, you have to work on the training, and you have to find, you have to train, and then again you have to find the distances and distances with the centroid. Okay, the centroid, and you have to find that which the distance is minimum. So you have to do, we will understand exactly how it works. Okay, so you have decided that these three data points 1, 2, 3, 1, 2, 3, these three data points belongs one cluster. So you have to find out the centroid of these three data points and these two data points, the centroid. So now how can you find? So you have to add the feature wise 1, 2, then 4, then divide by 3, then other will be, this will be for the 1, and for the V2 you'll get 1, 1, 1, 1, sorry, 1, 1 plus 5 by 3. Okay, so on the basis of this thing you can see 4, 6, 7 over 3, and this will also be 7 over 3. Okay, so you'll get a centroid, that is this 7 over 3. This means it will be 2.33 something, and 2.33. Okay, so you'll get centroid of this cluster. Now you have to find out centroid of this cluster. So what you will do? 7 plus 5, 5 plus 7 you add. Okay, nice. So by 2, and 7 plus 7 by 2. So you see 6, 12, 7, 6 and 7. So for this centroid, you will get 6 and 7. Okay. Now, when you decided that, when you find the centroid, computed the centroid, here we'll see in the second next slide. When you find the centroid, now what you have to do? You have to find the distance from the centroid to each data point. Okay. This also. So this, and from this data point, this data point. So means the data points, find the distance from of each data point from the each centroid. Okay. So within the center you don't, yeah, within center also. Okay, you find. Let's move to the second slide. So you have created, you have find. Yeah. So see here what will be. Okay, centroid we have created. This is the center 2.3, 2.3, and 6.5. Now what cluster? So distance you make the cluster centroid is 2.33, 2.33, and the first data point is 1, 1, 2, 1, 4, 5. This, so you are going to find the distance of the first data point from the centroid. Distance of the first data point from the centroid is 1.89. The distance of the first data point from the centroid of the second cluster, the cluster B. Likewise, you have to calculate all these things. Okay. So item 2 is in itself in the cluster A, so that you can find 1.35 or 37. That is the second data point, the distance of the second data point from the cluster A centroid. Center A, cluster A centroid. The item means data point 2, the distance of data point 2 from the centroid of cluster 2. So in this way you have to find out, and on the basis of now you have to check that whether this data point is more closer to the centroid of A or the centroid of B. So on the basis of this we can say that this is 1.89, that is minimum. So item 1 is more closer to the centroid of cluster A. So we will go this item 1 will go to cluster A. Item again reassign, we are going to reassign to the respective cluster. Item 2, the distance of item 2 from the cluster A and from the cluster B is, so again we can say that item 2 is going to A cluster. Okay, now we calculated the item 3 distance from the centroid of cluster A and cluster B. So you can see here this distance is minimum. So now item 3 will belong to cluster B. Earlier when we initialized that item 3 or the data point 3 is belonging with cluster 1, cluster A. Now when we find the centroid and we take in the distance of each data point from the two centroids, then we find that the item 3 is now belonging to cluster B. So we assign cluster B. Now these things will remain same because these are the distances or the minimum one. So 4 and 5 will also belong to cluster B. So this way we have to find out the cluster, and then we have to find out the distance of each data point from those clusters, and we have to reassign on the basis of the distance. So this will be, you will see that now this cluster A will contain data point 1 and 2, cluster B now contains 3 and 4, 5. So again you have to calculate the centroid, okay, of these two data points, and now here 3 data points are there. So now you will get 1.5 and 1, and then this again you have to calculate the distance of each data point from the each cluster centroid. And if there is no changing in the cluster assignment, then what you will do, you are going to stop, because you reach at the optimal level of the clusters, that now the data points are not going to reassign to a different. So these two data points were in cluster 1, and these 3 data points were in the cluster B. So it was earlier iteration, this was the assignment. Now still this is the assignment, so there is no changing in the cluster point, so we are going to stop here. Okay, so this way you can go with the k-means clustering. So other thing, we will go with university and we will check, and what are the things that we will say elbow method to decide how many what are the number of the clusters, optimal number of the clusters are. Okay, so this one is the elbow method, and another one is the Silhouette method that I have not written here. So we will go and we will check in the our Jupyter notebook, and we will draw all these. Okay, we will find the diagram for the elbow method and Silhouette method also. Okay, so one thing that I wanted to show, that if you have taken number of the cluster 3, so let's say in 3 clusters you will find these clusters. Okay, number of the clusters. So let's say you started from here, you started from this is the you initialize that the these data points, these um, data points are the examples will be in one cluster, and these will be another, these will be another cluster. Okay, so you can find that these will be the centroid. These will be the centroid. How? I think we have here. Yeah. So let's say first three you have, first three data points you are trying to club in one group. Okay, so for this centroid you have to add this, divide by 3, add this, divide by 3, add this, divide by 3. These things you can find out the centroid. Next, these, let's say you put it into another group, so add these and divide by 1 2 3 4 5 6 7 8 9 10 11 by 11, so you'll get the centroid. Okay, so that is basically given here, the centroid of the clusters. You can find it. Okay, so these are the clusters and these are the centroid of the clusters. And on the basis of the centroid of the clusters, we can make some inference that these are the these will be the average or the mean site score. This will be the top 10 score. Accepted score will be the mean. Accepted score will be 67 point base. Okay. Expenses, average expenses of all the elements in this, of all the data points of the universities in cluster 1 is 13,384 something. Okay, and grade rate is 73 or 74 in the cluster 1. So while finding the mean, okay, so cluster, you can find some intuition. You can find that the on average, all the data points in one cluster have the same feature or the same values. Okay, but it will not be exactly same. It is the average or the mean or the center. So if you go for the 3 cluster, then you will find like these 4 cluster, 5 cluster, 6, 7 clusters. Okay. So on the basis of number of clusters, here you will get the number of clusters, 2 cluster, 3, 4, 5, 6, and you find the average within cluster distance. Try to find out the average within cluster distance. So you'll see here this cluster and this cluster. So the cluster 1 and cluster 2, what is the average distance between the cluster, that we have seen, that how to find out the cluster distance between 2 clusters. Okay, so you draw the graph, you draw a graph between the number of the clusters and the average within cluster distance. This is distance. So you will find something. We'll see when we'll plot properly. We'll find that how many clusters are there. Okay, so it may be 2 cluster or 3 cluster, where like an elbow it bends more, something like that. Okay, so this will be, let's say this was the k equal to 2, this was k equal to 3, this was 4. So this is more likely the optimal number of the clusters. Okay, so let's move to the Jupyter notebook. If you are using Jupyter, then open the Jupyter notebook. Either you can open your that Colab, okay, Google Colab. So you may work on the Google Colab. Similarly, you may work on the Jupyter notebook here. So let's move to the Jupyter notebook. Again, I'm saying you can download these. Go here. Okay, go to like okay, you go here. The link is there. Same link. I'm adding day by day. Yesterday you have whatever you have downloaded. Okay, so I'm adding day by day all the respective files here. You can go for the same. Okay, this will be the main one for the this. Okay, FSD full stack development and ML. You can go for this, and you will find the file. Okay, so unsupervised learning, you go into the unsupervised learning. Yeah, just let me paste here the same. Okay, so you can download the university CSV, customer CSV, and these files. Okay, these files, we have two IPYNB files. Okay, Jupyter files, notebook file basically, and these two CSV files that we are working on, these two data. So let me open the k-means cluster. Okay, so earlier I have worked on the collab. So just if you are working on collab, so you need not to change anything. But if okay, so if you are working in the Jupyter notebook on your local machine, so you can so again sklearn, you can go to the official website for sklearn. What is that? K-means. Just go for the K-means. You will get the K-means, and you can find all those things. Number of clusters, what is this, necessarily number of iterations, means how many times you are performing number of iterations. So as when your data set is bigger, you have large number of the features in your data set. So you need many iterations. Okay, so this is default 300 iterations. Okay, so these things are there. You can go and read properly. So there are different methods that you can use. Fit predict. So when we are working on like unsupervised learning, clustering methods. Okay, so basically there is no output features, no target variables are there, no target values are there, no classes are there. Okay, so that you can directly go, you can directly okay, yeah. So you have all these things. So you can work directly fit predict. Okay, so you'll see all these things. So just what we need k-means from sklearn.cluster. Okay, so as usual, NumPy, Pandas, Matplotlib, we are using these always for different purpose. Okay, because these Pandas is required for the reading our data set, and Matplotlib for the plotting purpose, plotting the so display the plots. sklearn, from sklearn, that is the important library, machine learning library that we are using from last 3-4 days. Okay, sessions. So cluster, for the cluster you are using the k-means class. Okay, so you go in technicality. So this is k-means is basically a class of this module, and this is sklearn, it's your lab. So run this, and your data set, you'll get your data set customer.csv. In previous class, that agglomerative clustering, hierarchical clustering, we use this customer. Okay, so same way we'll go and we'll see that how what is the difference, is there any difference, or which one method is easy to perform. Okay, so customer data set, again you will see that customer ID, gender, age, annual income, and the spending score, all these things. And you can find information also, your data frame. DF is basically your data frame. Okay, data frame.info. So you'll get all these things, number of the columns, column values, column names, basically customer ID, gender, age, all these things. So is there any value is null? No, all values have 400. So you can find data types and all other things. So we are going to plot only these two. Okay, earlier we have done these in the agglomerative. So that's why I am going fast. And we will take these two data point, these two features, the spending score and the annual income. Okay, so we will plot scatter plot. Okay, so in that we plotted a scatter plot using matplotlib. Now here you can see here that a data frame, pandas data frame, pandas library have also a plot dot scatter plot method. Okay, to plot scatter. Okay, so you can just run this and you can plot scatter plot and it will give you the things. Okay, annual income and the spending. So you can find that how your data points are scattered. Okay, so you can guess that these data points may belong into same group. Okay, same cluster. This may belong into same cluster. So in this way you can check. Okay, now you have to create your model. Okay, basically. So k means that we have already imported. This k means is a class, and this class takes different number of different parameters, different values you need to pass. So one is number of cluster. That is very important that you have to pass. If you are not passing, then default is 8. Okay, and initialization, how you are going to initialize this is k means plus plus. This is a method of initializing the uh, initial cluster for the data points. Okay, so initially it will initialize the the cluster, and it will assign the data points to respective clusters. Okay, so this is init, and max iteration. Okay, so how many iterations you need? So maximum default is 300. You may give this small lesser number like 10, 20, 100. Okay, so if your data set is not too huge or your data set having not many features. Okay, we have only 2 features and 200, only 200 data points. So no, not needed that you go up to the 300. Okay, 300 iterations. All the other things are that's the algorithm and other things you can check. Okay, so we have taken this k means class, and using this k means class we are passing number of cluster as 3 and max iteration is equal to 100. So this will be your object. This is your object, and that is object of this class. Okay, this is a class and this is object. Okay, in Python. And this is basically a model in when we are talking about the machine learning. So this is k means is basically our model, and this model we are going to train and predict. Okay, we are going to use this to train on this data and predict. So what you will do, just find your the data points basically that we need only the annual income, annual income and the spending score, these two. We are working on these two only because the gender is categorical and we are not working on this customer ID is 1, 2, 3. It is default one. So age is also, we are skipping the age column also. We will work on only these two. These two features are the most important features when we are going to decide when we are going to make a cluster. Okay, so let's say that our data that we need, the data that we need is basically these two columns, these two features, only annual income and spending score. So just this is your model. Model is k means. The model variable, that is the variable name of the model is k means. Now you are going to fit. Just you fit k means is not defined. Okay. So I have not run this one. So just run this and your data this. Okay. So now this will show that your k means model is fitted with this data, that these are the data points 1539, 1581, all these. Okay. So you'll get all these things. Yeah. So now what we have to do, you can find labels. Labels means the number of the cluster. Number of cluster is 3. You decided 3 clusters. So you'll get 0, 1 and 2. These will be the labels. Okay. So label 1 belongs, these data points, the last data point belongs to label 1. The first data points belong to label 2. Okay. So number of clusters are 3. Numbers of cluster 3. So the labels will be 0, 1, 2. So what you will do, now we get the labels. Now you can find the figure. Okay, you can draw the figure that will be. So we have said that we need only we need only 3 clusters. Okay, so this is the red data points are in one cluster. This green and the blue are in one cluster, and the X data point is basically the centroid. Okay, the centroid represents the mean of all the data points feature. Okay, feature values. Okay. So now you can find the mean. Actually, you can find the mean how? K means the model dot cluster centers, and then this you will get the mean. Okay. So this 87 and 18 point, this is the cluster center for the first cluster, and this 86 point this, and this will be the cluster for the second, something like that. You will get all these things. So you can find the centroid of the clusters. Okay, these are the centroid of the clusters, and this is what. Okay, so now you can club the data point, these data points with these data points with the cluster label. So you can use data frame, and then this k-means cluster, you'll get column, then give the names, what are the columns, and then you can find the this thing. This will cluster 1, cluster 2, cluster 2. This is basically to find the cluster centroid. Okay, cluster centroid for the clusters, 3 clusters. These are the clusters. So we created a data frame of the cluster centroid. So this is same. Okay, these values are the same values, but we have given the actual these things. The annual income is 87 for the cluster 1. The annual income for the cluster 2 is 86.5. Annual income is 44 point something for the cluster 3. These are the centroid, and these are the mean of the all data points that belong to the cluster 1 is basically 87. Okay. So how to decide that we are going to find only 3 cluster, or we are going to find 4 or 5? So that is the most important method, that is elbow method. So what we will do, we will make a loop and we'll try to find out that when the cluster is 1, when the cluster is 2, when the cluster is 3, go up to 11. You can go up to 10, 20, 15, something like that. And initialization is this, all the things that we have seen. Okay, so k-means you take, so you have to find out different k-means methods, and you have to find out this way. You have to draw the graph. Okay, so you will draw the graph that inter cluster average inter cluster distance that we have seen in the PPT. Okay, so this will be inter-cluster, average inter-cluster distance, and this is the minimum, the number of the clusters. Okay, this is basically number of the cluster. Okay, so you can see here. So if number of clusters is 2, you can find here. If number of cluster is 2, so this is here. If number of cluster 2, number of cluster. So this way. Now what? How can you decide this point at this point? These 2 points are there, plus at 3 and at 5. Okay, where the bending is the maximum. This is or the bending you can say, are the yeah, bending you can say. So like curve has bended, so you can decide that whether 3 or 5. Okay, where the bending is much more. So let's go to the next one, that is Silhouette method that we have seen. You can find the for the cluster 5 also. Okay, so you can check here. You can go and rerun the program with number of the cluster as 3. Okay, so another method is Silhouette method that will give you the Silhouette score and the number of the clusters. So you have to check all these things. That again you have to find out how many clusters. You have to loop through 1 cluster, 2, 3, 4, 5, 11 clusters, and you have to find the average Silhouette score. So you'll find the average Silhouette score, and you'll see that where the Silhouette score is maximum, that will be your the number of the cluster. Okay, so that will be the number of the clusters. So this way you can find the optimal number of the cluster. So this way you can work on the university data for all these things. Whatever we have done for the customer data set, you can do on the university data set also. Okay. So up to this, if you have any doubt or any query, so we can take. And meanwhile, let's complete these things. So if you are working in Colab, so it is fine. Upload your data set and do as it is. But I'm working in my Jupyter notebook on the local machine. So just all the import things, all the import and other things is same. All the import related things are same. Just to where it is, yeah. Just import the data set. So university data set we have taken, and you can find that how many university data sets are there. So from 0 to 24, 25 entries, 25 data points we have, and each data point contains 1, 2, 3, 4, 5, 6, 7. 7 features, 7. Yeah. So these from set score to the grade rate, these 6 features are basically important features that are the deciding features, deciding factor in the clustering. Okay, the name of the university is not going to help us more, so we'll keep. And yeah, so just find out the Silhouette score. So you will find that for the number of the cluster, that is 3, number of the cluster that is 3 is the optimum value of the cluster, means the actual value that here for the university data set, the number of the cluster is basically 3. So on the basis of the Silhouette score, you can find this way. So when we decided that number of the cluster is 3, so you can go and directly work on the import the k-means, and then write the number of the clusters and other things. You can write different other things, but all other things will be number of the iterations, max iterations, and all these things will be taken as default if you are not assigning, you are not passing these values. Okay, so if you are not passing, so maximum number of the iteration will be 300. You can pass something 300 or 100 or 20, 30, something like that. Okay, so this model k-means underscore model is your model. This is an object. You created an object of k-means class. Passing n number of it means passing n clusters. Well, so now just you fit This we are going to feed the data, university data, and we are taking from 1 to 7. 1 to 7 is basically, this is 0, this is 1, 2, 3, 4, 5, and this is 7. So 1 to 7 we are taking. And no, not it will be not 7, it will be basically the 6 one, 0, 1, 2, 3, 4, 5, 6. And 7, why we have taken 7? Because the last one is not included. Okay, so in the range when we are writing in this in Python, so 1 column 7, so it will go from the column index 1 to 6. It will take the 1 to 6. Okay, the last the end index is not included. So just import. Okay, so where we went. Okay, so you made the model, now just fit the model, and now just you get the labels. So you get the label, you can find out the cluster centers, you can find out the cluster labels, create a cluster label, you can concatenate cluster labels with actual data points. So you have calculated, you have concatenated the data points with clusters. So you can see here the university, first university, Brown University will belong to the cluster 2. Caltech University will belong to cluster 1. CMU, Columbia will belong to cluster 0. This way you can see all the things. Okay. Penn State University, Princeton University will belong to 0. Purdue University will belong to this. On what basis? On these scores, on these values, on the basis of these values, it will belong to the similar universities will belong to the same class. Okay. So I hope the clustering you get some intuition, you get some value, you get some knowledge on the clustering. And we have seen two different methods. K means clustering, and the other one is agglomerative clustering. That was basically a hierarchical clustering technique. Okay. And for each clustering algorithm, for each clustering technique, we have seen we have implemented on two different data sets. One is basically the university data set that you can see here. This was the university data set. This was basically for the admission purpose, that what is the set score, top 10 and accepted value, what all these things are there. And other data set was the customer data set. So this is customer data set or the university data set. So we have we made the clusters of the respective data points are the customers. So I hope that yeah, so it's time to conclude here. So for the tomorrow session that we will take, we have covered supervised and unsupervised learning. In supervised, we have covered regression and classification, and in unsupervised, we have seen the clustering today. Okay, so now we will move ahead and we'll try to do from the starting from the data point to we will move to the project and we'll try to work on the data set, and so we'll do some data pre-processing, feature engineering, and then move to the model evaluation. And we will see that if we are doing a task, suppose we are doing a classification task, so we'll implement different, let's say 3, 4, 5 different methods. We'll try to train 5 models Okay, and we'll see that which model is working better and how the model will be evaluated. So we have to see in the model evaluation also and all these things. Okay, and then we will try to save our model, and after saving model, we will try to implement, we'll try to deploy our model. So we will see all these things in upcoming sessions. So I hope it's time to conclude here. So Susmita ma'am, I think we can conclude here.
Yeah, sure, sir. We can wind up further.
Okay, ma'am, thank you.
We will meet again by tomorrow at 7 p.m.
Yes, yes, ma'am.
Thank you, sir. Thank you so much for your valuable time.
You're most welcome.
Yeah. So yes, students, so we will wind up for the day. We'll meet again by tomorrow at 7 p.m. Thank you all. Good night.